We're in the mountains of southeast Tennessee. Beautiful hills, deep forests, and rugged terrain. But we aren't here for the scenery. We're here to build a mountain road. And this road is different. Instead of traditional asphalt, this community is being built with roller compacted concrete, or RCC, a pavement that needs no rebar, no forms, and can support traffic quickly. RCC isn't new. It's been used for decades in ports, industrial sites, and other heavy-duty environments. But here, it's being used in a new way, to build the internal road network for a massive residential development. This project, River Gorge Ranch, covers more than 7,000 acres. To reach every lot, normally, asphalt would be the default choice. The original plan called for 2 inches of hot mix asphalt over 6 inches of base material. But with a 6 to 7 year construction schedule and constant heavy truck traffic, the owner was concerned that the asphalt layer would deteriorate quickly. The owner wanted a durable pavement which could be placed and open to traffic quickly. RCC offered a stronger, longer-lasting, more economical approach. The 22-foot wide roadways are being paved at an 11-foot width using a high-density paver, providing continuous access to the existing home site under construction. The pavement design uses 5 inches of RCC over 6 inches of base material for roadway pavement and 6 inches of RCC in cul-de-sac to withstand truck U-turns. For this particular project, this system costs only about 15% more than asphalt, yet delivers vastly superior durability and life cycle performance. Because RCC can handle heavy repeated loads, the same pavement used during construction becomes the final road, eliminating costly repairs or replacements of damaged asphalt surfaces. Once complete, over 45 miles of RCC roadway will be in service at River Gorge Ranch. How RCC is produced and placed. RCC is a stiff concrete mix that looks more like damp aggregates than traditional concrete. It's made from well-graded sand and stone mixed with appropriate amounts of cement and water. RCC doesn't require forms or reinforcement. To produce RCC, mobile pug mill plants, which are ideal for stiff mixes, are set up on the job site. Rock and sand are stockpiled, and cement is stored in silos. After adding a low quantity of water, materials are continuously mixed and loaded into dump trucks. Once loaded, trucks must travel a short distance to the paver. Travel time should be kept under 15 to 20 minutes, and the mix should be placed and compacted within 60 minutes of batching. These times may be adjusted depending on the environmental conditions and use of chemical admixtures. The paver, similar in appearance to an asphalt paver but equipped with high-density compaction devices, places the RCC and achieves the initial compaction. Rollers follow behind to achieve final compaction, typically up to 98% of maximum wet density. After placement, RCC typically needs only 3 to 4 days to reach enough strength to carry construction traffic, although light vehicles can often drive on it almost immediately. Pavers use laser guidance to control lane width and elevation. Any high spots can be removed with diamond grinding. In some cases, RCC can be troweled to improve surface texture and provide an appearance similar to conventional concrete. A curing compound is sprayed onto the fresh pavement to control moisture loss and help ensure design strengths are met. RCC design strength targets vary based on the application type. For a residential roadway, a 4,000 psi compressive and 550 psi flexural at 28 days requirement is common. Similar to conventional concrete pavements, construction, isolation, and expansion joints are often incorporated to control cracking. RCC can be supported on a wide range of base structures depending on soil quality and expected load. On good granular soils, like those found on much of this Tennessee site, a simpler section of 6 inches of crushed stone base material beneath the RCC is sufficient. For poor soils, or in high-load facilities like a container stacking operations, more robust pavement sections are often required. A qualified pavement design engineer should always determine the proper section for the expected load and soil conditions. Why RCC makes sense here. Mountain construction is demanding. These roads must carry heavy trucks every day for years while the development is built. RCC provides strength that resists rutting and deformation, minimal maintenance during construction, long service life with low cycle cost, fast installation, superior performance on steep grades and tight curves. This project demonstrates what RCC can do. build faster, last longer, and reduce maintenance and rework. For large-scale residential developments with long construction windows, especially in challenging terrain, RCC is not just an alternative. It is often the best overall pavement solution.